Virtual reality is a computer-generated simulation of a three-dimensional environment. Using headsets, learners can be transported into a fully immersive digital world, like exploring a volcano from the inside or walking on the surface of Mars. Augmented reality, on the other hand, overlays digital information onto the real world. Using mobile devices, tablets, or smart glasses, learners can point their camera at a diagram and see it come to life in 3D, like a beating heart or rotating DNA strand. These technologies allow learners to interact and step into their learning in engaging ways, whether it's the bloodstream, the solar system, or DNA strand. In STEM education, concepts like chemical reactions, gravity, circuits, or anatomy are difficult to visualize. With VR and AR, learners move from theory to experience. It helps bridge the gap between abstract content and real-world application. According to Guido 2017, inquiry-based learning is a learner-centered approach that encourages learners to ask questions, investigate solutions, and actively construct knowledge. Instead of memorizing facts, learners explore problems and work collaboratively to find answers. VR and AR enhance this approach by creating environments where learners can experiment, manipulate data, and visualize complex STEM concepts in real time. AR and VR supports the CAPS in equipping learners with 21st century skills. Imagine being able to simulate a dangerous chemistry experiment safely or visualize mathematical functions in 3D. In science, learners can use VR to explore ecosystems, conduct virtual dissections, or even simulate physics experiments. In mathematics, AR can help visualize geometry or explore graphs by manipulating them in real time. These technologies make abstract concepts tangible, supporting exploration and deeper learning. According to Educator Insights, teachers describe authentic learning as a teaching strategy that connects classroom content to real-life applications. With VR and AR, learners can simulate careers in medicine or engineering. They engage in real-world problem-solving, like calculating force needed to launch a satellite or diagnosing a disease. Students aren't just learning, they're doing, testing, and discussing. That's what makes the learning authentic and inquiry-driven. Inquiry-based learning and authentic learning is especially powerful in the South African context, where schools in under-resourced areas can now access rich educational experiences. Although access to education is still unequal, with growing access to mobile devices and internet, AR and VR can help close that gap. Low-cost solutions like mobile AR apps allow schools, even those in rural areas, to implement immersive learning. NGOs and government initiatives like the Department of Basic Education's e-education policy are promoting digital literacy and the 4IR in schools. Of course, there are challenges such as funding, teacher training, and internet access, but the potential for transformation is huge. Besides mastering content, learners also build 21st century skills: critical thinking, collaboration, and creativity. Through VR, collaboration, learners in different provinces can solve challenges together in the same virtual space.